All right, today we're going to crack the code on a legendary system design interview question, how to design something like Amazon S3. And look, this isn't just going to be theory. We are building a practical, step-by-step playbook, the kind that gives you the structure and, honestly, the confidence to really shine when the pressure's on. So let's dive right in.
So we're going to tackle this in 5 key stages. First, we'll pin down what the problem actually is. Then we'll architect the core system. After that, we'll get into the really hard problems, the stuff that makes it scale. And finally, we'll wrap it all up with how to nail the interview itself. And this structure, it's not just for us here. This is the exact roadmap you should be using in the interview to guide the conversation. It shows you think clearly and methodically.
Okay, so let's set the scene. Picture it. You're in that final round interview at, a top tech company. The pressure is definitely on. The interviewer kind of leans forward, looks you in the eye, and hits you with the big one.
Yeah, it's a beast of a question, right? It's designed to see what you really know about scale, durability, and consistency. But don't worry, we're going to take it apart piece by piece. Before we even think about drawing a single box on the whiteboard, let's make sure we're all on the same page. What exactly is Amazon S3?
So, at its heart, S3 is just a giant object storage system. It doesn't really use folders in the traditional sense. Instead, you have these things called buckets that hold objects. And an object? It's just a file plus some extra info about it, metadata. The real kicker here, the thing everyone talks about, is its legendary durability. We're talking 11 nines of durability, which basically means your data is ridiculously, unbelievably safe.
Okay, now listen, this is probably the single most important move you can make in any system design interview. You have to pump the brakes. Before you start drawing diagrams or talking about servers, you have to clarify the requirements. Seriously, this isn't just a friendly suggestion, it's the one thing that immediately separates a senior level answer from a junior one.
So for our design, let's agree to focus on these 5 core functions. But pay super close attention to the details here. Like, we can only delete a directory if it's totally empty. And this next one is huge. Files are immutable. That means once you write a file, you can never, ever change it. That one decision right there is probably the most important one we're going to make. It's going to make our lives so much easier and simplify huge parts of the system, as you'll see in a minute.
This right here, this is the heart of our whole design. Think about it. By making the files themselves immutable, write them once and then just read them as many times as you want, we just dodged a massive bullet. We don't have to worry about all the crazy complex problems like locking a file because 2 people are trying to edit it at the same time. Gone. But the directory structure, the metadata that says what's where, that's a whole different story. That stuff is changing all the time. And for that, we have to be absolutely militant about consistency. We need transactions. Otherwise, the whole system just descends into chaos.
All right, ground rules are set. Now it's time to actually start building this thing. Let's start sketching out the blueprint. And we're not going to design this as one giant, messy monolith. No way. We're going to build it out of distinct, specialized pieces, where each one has a very clear job to do.
So here are our main building blocks. You can kind of think of it in layers. Up top, you've got the API gateway. That's the front door for every single request. Behind that, the file service is like the central brain, orchestrating everything. Now this is super important. We're separating the metadata, the directory structure, from the actual raw file data. That data is handled by the chunk manager and gets stored on literally thousands of storage nodes. Oh, and we have a garbage collector, which is basically a janitor that runs around in the background cleaning up old data blocks that nobody's using anymore. Okay, pay attention here, because this flow for creating a file is one of the most critical ideas to get right. First, the client sends a file. We chop it up into smaller chunks. We then copy each chunk and store it on multiple machines for safety. And only when we get confirmation that all those chunks are safely stored, then we create the metadata record that points to them. This pattern, say it with me, data first, metadata last, is absolutely fundamental for building systems you can trust. It completely prevents that nightmare scenario where your system thinks a file exists, but oops, the actual data never got saved. Reading a file is pretty much that whole process, but in reverse. First, we look up the file in our metadata store to get the list of all its block hashes. Then we ask the chunk manager, hey, where can I find these blocks? And then we go fetch all of them at the same time in parallel. That parallelism is the secret sauce. It's how we get really, really fast reads, especially for huge files that are spread out all over the place.
This is a trap that so many engineers fall into. They get all excited and obsessed with the challenge of storing petabytes of raw data, the big stuff. And they totally forget that managing the metadata, all those tiny little records about where everything is, that's often the real nightmare when it comes to scale.
Your metadata store can't be an afterthought. It has to be a first-class, high-performance part of your system right from the get-go.
Okay, so we've got a working system. That's a great start. But a working system isn't enough to really impress in one of these interviews. To do that, you have to lean into the hard problems. This is where you show you're not just a junior dev. This is where you demonstrate that senior-level thinking about scale and consistency.
To really get a feel for the kind of scale we're talking about, let's just throw a number out there. Let's say we have 200 petabytes of user data. And for durability, we're making 3 copies of everything. That's 600 petabytes of physical disk space we need. That's just a mind-boggling number. So the question isn't just where do we stick all this stuff, it's how on earth do we build a system that can manage it all without just completely collapsing?
Look, there's only one way to handle that kind of scale. You have to scale horizontally, meaning you just keep adding more machines. But you can't just do it randomly. You need a smart strategy for each different part of the system. For the metadata, we can shard it, maybe by customer ID or by the file path. For the chunk manager, which is getting hammered with requests, we can partition it by the block hash. And the data itself, yeah, that gets spread across something like 6,000 different machines. And by the way, using rough numbers like this in an interview is a great move. It shows you're actually thinking through the problem, not just hand-waving.
Now, for that other really hard problem, consistency. So what stops 2 different requests from trying to change the same directory at the exact same time and just making a huge mess? Well, we need a defense-in-depth strategy. First, every single change to our metadata is wrapped in a proper database transaction. It either all succeeds or it all fails. Second, we use what's called path-level locking, which means only one person can mess with a specific directory at any given moment. And to manage those locks across all our different servers, we use a battle-tested tool like Zookeeper. You put all that together, and it guarantees our file system structure stays perfect, no matter what.
All right, we've designed the system, we've scaled it, we've made it consistent. Let's boil this all down. What are the absolute key takeaways? What are the common mistakes people make? Let's make sure you walk into that interview completely prepared to nail this question.
Think of this as your last-minute checklist before you walk into that interview room. 1. Did you make it crystal clear that files are immutable, but directories are mutable? 2. Did you call out that metadata is a huge potential bottleneck? 3. Did you have a rock-solid plan for consistency when changing directories? 4. Did you follow the data first, metadata last rule? And 5. Did you remember to talk about garbage collection? If you can tick all those boxes, you are in a fantastic position.
And just when you think you're done, be ready for this one. It's the classic what's next question. They want to see if you can think bigger than just the basic requirements. What would you add? Maybe file versioning or more detailed security permissions? What about rules to automatically move old data to cheaper storage? Having a good answer ready for this shows you're not just a coder who follows instructions. It shows you're a product-minded engineer who can think about the future of the system.